Hey there, Mr. Weaver here, and this is lesson 2 on complex inequalities. After this lesson, you need to be able to solve complex inequalities involving distributive property and with variables on both sides. You'll know you're successful after this lesson if you can use the rules for distribution, for variables on both sides, and because we're dealing with inequalities, we need to watch out for those negatives. So using those as well to solve complex inequalities. So just like solving simple inequalities, we followed the same steps that we did when we were solving equations. Multi-step inequalities or complex inequalities, we're going to solve them the same way that we did as complex equations. So the steps are the same as they were with the equations. We're going to first distribute if we need to. Then we'll combine like terms. Then we're going to isolate our variable. And then again, the one difference for inequalities compared to equations is with inequalities, we need to remember to flip that inequality sign if we are multiplying or dividing by a negative number. So let's look at a couple different types of inequalities, some with distributing and some with variables on both sides. So first, we have an inequality here of 0.5x minus 5 minus 3x plus 9 is less than or equal to 14. So again, we're going to go through those steps: distribute, combine, isolate, flip if we need to. So first, there's nothing to distribute here. So then we're going to combine like terms. So I see there are two x terms, 0.5x and minus 3x. So together, 0.5 minus 3 is negative 2.5, and that had the x. And then I also see there's a minus 5 and a plus 9. So negative 5 plus 9 is positive 4. Just by combining like terms, we simplified it quite a bit. Bring down the rest, and now I'm left with negative 2.5x plus 4 is less than or equal to 14. Now we're back to a two-step equation, so subtract the 4 from both sides. I end up with the right side to be 10. Our sign isn't changing yet. Bring down the rest. Divide by the coefficient of x, so divide by negative 2.5, which is 4. And we would get x and negative 4. And because we divided by a negative, we needed to flip that sign. Right? So don't forget to flip the sign when we're dividing by a negative. Just like in the last lesson, that is our boundary. So we still need to graph it on a number line. So here I would have negative 4 as my boundary where my circle would be. It's colored in because of the symbol that was used. And because x is now greater than negative 4, my greater numbers for my variable are to the right. So my arrow would go to the right. Now it's your turn. Pause the video, combine like terms, simplify, solve for the variable. Don't forget to flip your sign if you need to, and then graph it on a number line. See how far you can get. Let's check. When you combine like terms, you should have ended up with 2x and plus 37, still greater than 49. So solving, you would subtract 37, divide by 2, you would get x is greater than 6. Should we have flipped the sign? You divided by a positive 2, so the sign should be the same as the original, which means an open circle at 6, and since x is greater, the arrow is going to go to the right. Let's look at another example. So solve negative 4 times the quantity 3x minus 1 is less than 16 minus 6x, and graph the solution. So I'm just rewriting the problem. First, we're going to need to distribute. So I see that number outside of parentheses. I'm going to multiply that through, and I would get negative 12x plus 4. Remember, a negative times a negative makes a positive, so -4 times -1 becomes +4. Bring down the rest. Now, I have variables on both sides, so I just need to do the opposite of what I see to both sides until I'm left with a variable on one side and my value on the other. So first, on the right, I see that -6x, so I'm going to do +6x to both sides. That will cancel the x out from the right. So -12x plus 6 becomes -6x, and then bring down the rest, +4 is less than 16. Now, my x is on the left, so I need to get rid of the number on the left. So subtract 4 from both sides. Doing this, I would end up with -6x is less than 12. Divide by -6, and I would get x and -2. Because I divided by the negative, I had to flip my sign to the opposite direction. So x is greater than -2, and that's our boundary. So when I graph it on a number line, I would put my circle at -2. It's open based on the sign, and because x is greater than -2, my arrow would go to the right. It's your turn again. Pause the video and solve your inequality for x, and then graph your solution on a number line. Let's check. So rewriting the problem, distributing out, you should have got -6x plus 4, bringing down the rest, add 6x to both sides, or you could have subtracted 8x, which would simplify down to 4 is greater than or equal to 6 plus 14x. Subtract 6 from both sides. -2 would be greater than or equal to 14x. Dividing by 14 then, and you would get -0.143 is greater than or equal to x, or x is less than that number. Had you subtracted 8x in that second step, you would get the same answer, and you would end up dividing by a -14. So you would have to have your sign flipped, but you should end up with the same boundary. When we graph it, -0.143 is just a little bit left of 0. And then because x is less than that number, the arrow goes to the left. All right, let's look at some real world situations where these inequalities can come in handy. So Derek wants to order some roses online. For what number of roses is it less expensive to order from Florist A? Florist A charges $4.75 per rose plus a $40 delivery fee, while Florist B charges $5.15 per rose plus a $25 delivery fee. So we can see that Florist A is cheaper for the roses but more expensive for delivery, while Florist B is cheaper for the delivery but more expensive for the roses. So we want to know, when is it less expensive to be from Florist A? So I need A to be less than B. If we're writing our equations, Florist A is $4.75 per rose plus $40 fee. And I need that to be less than B, so less than 5.15R plus 25. Once I have my equation written, I'm just solving with a variable on both sides. So I'm going to subtract $4.75. Thinking back to our lessons in topic 1, I tend to subtract the ones that are smaller, then my number stays positive. So subtracting $4.75 for a rose from both sides, bringing down the rest, I would end up with 40 is less than 0.4 R plus 25. Subtract 25, and we would end up with 15 has to be less than 40 cents per rose. Dividing by 40 cents, roses R is greater than 37.5. Another way to think about this problem is thinking along the lines of how much more does Florist B charge per rose? So that's 40 cents more, which is what we got. Okay, and they need to make up an extra $15 for delivery. Now, if we graph it on a number line, our boundary is 37.5, so our open circle would go at 37.5, and we want the R, roses, to be more than 37.5. So if he orders more than 37.5 roses, then it's going to be cheaper. And that's assuming he had chosen that number and compared both places. Now, we're not going to buy half of a rose, and they're not going to sell you half of a rose. So we're going to pick the next possible whole value in this situation, which is 38. So if Derek wants to order from florist A and have it be cheaper, then he would need to order 38 roses. Now it's your turn one last time. Read through the situation and see if you can figure out when Charlie should order from company B and still save money. Don't forget to use a number line to graph your solution and also now to help you decide what the final answer should be. Let's check. So we want company B while still saving money. So this time B needs to be less than A. So B is $12 per person plus $35 fee, while A is $8 per person with $150 fee. If we subtract 8P, that would show that the difference of people is 4P, and if we subtract 35, that would show the difference in setup fees is 115. So that extra $4 per person needs to make up for the excess $115 setup fee. So if we divided by 4, we would find that P is 28.75. So to help us decide how many people we end up wanting to actually be able to have, 28.75 is our boundary, and we want B to be less, so we need less people. So our highest whole number closest to that, 28 would be the most people that he could have while using company B to save money. Once he got to 29, then we would want to switch to company A. In this lesson, we learned that when we're solving inequalities, even the more complex ones still follow the same rules as equations, except when you multiply or divide by a negative. Then you gotta remember to flip the sign. Still, when you're graphing, okay, the greater than or equal to and less than or equal to signs, they are closed circles to show that that number is part of the solution. And if we have the greater than or less than signs, then that part cannot be part of the solution. The arrow, again, is drawn to show all of our possible solutions that fit the situation. And that arrow can also be helpful in context. So, for example, if you're solving an inequality and you find that a restaurant can hold at most 48.5 people, well, since you can't have half of a person, you would choose the next whole value that fits in the situation. Less than that would be 48. So the arrow can be very helpful in deciding which things fit. After this lesson, do you now know how to use the rules for distribution, variables on both sides, and our negatives to solve complex inequalities? If you're not sure how to do some things, go back and look at the different examples and see how these pieces help us to solve inequalities to help further your understanding of this concept. And that's the end of lesson 2 on solving complex inequalities and graphing their solutions.